Okay, this is another video, and this video is going to be homework number 2. Okay, so let's look at the answers for homework number 2. It doesn't help you if you don't have the answers, and it doesn't even help if you got the answers, like the answer sheet. It's not going to do any good if you do not have an idea of how I got those answers. So that's the reason for the videos. If we were in class together, this is what I would do in class every single time. You would come to class with your homework, and we would go over that homework every single time. That way you can know exactly what's right and what's wrong. Now, homework number 2, which is this one right here, should have already been turned in. And I'm having some questions from a few students. This is Tuesday, Thursday. Homework number 2, it says, is due on the 3rd at 12 p.m. And this is Monday, Wednesday. Homework number 2 is due on the 3rd at 12 p.m. It says p.m. as in noon, the afternoon, okay? And I'm getting students who are, messaging me, Miss Munson, this homework is not on there. I can't find it anymore. You're right. You can't find it. Can't find it because the moment it hits 12 o'clock, it disappears and goes away. It's set on Blackboard to go away. Remember, this is a fast-paced moving class. You have to stay on top of all your assignments, okay? Because if not, then the assignments are going to be disappearing. And you're going to get a 0 for them. So you have to get the work done. Okay? So let's go ahead and get started on accuracy and precision is where we're at right now. And it's what we're talking about. So what we need to know is the definitions of the two. So accuracy is how close a measurement is to its actual true value. Now, where do you find the answers to your homeworks? Well, here is one set of our notes, right? Unit 1 notes that look like this, Physics for Beginners. And then we have a set of notes that is the video notes as well. And then there was another set of notes that was the metric system notes. And that was like just a front and back page. All 3 of those notes need to be with you out and ready so when you do your homework, okay? The next word, precision. How close is a measurement is to each other. Has nothing to do with them being the exact number or correct. It's just that they're close to each other, okay? So now look at the targets below. Decide whether or not they're accurate, precise, both, or neither. So let's look at the first one over here. The bullseye itself in the center is going to be accurate. That is the correct place to hit it. But they did not hit it there. They got all of the targets to the side, but they got close to each other. So is it accurate? No. Is it precise? Yes. Okay. Now they got all of the bullseyes or all of the darts close in the center together. So is it accurate? Yes. Is it precise? Yes. Next one. Look at that. All over the place. This is like somebody who's never played before, right? Is it accurate? No. Is it precise? No. Now the pictures are super easy to do, right? But when we get to numbers, it becomes a little bit more difficult. So let's look down here. Okay. So on the bottom part, it says that there are 2 teams, 2 groups, and they both measure the density of aluminum. They didn't give us the actual density, so I don't know what the actual value is. So I'm not looking for the actual value or accuracy. I'm looking for each other, and I misspelled that. So I'm looking for precision. Precision means that they are numbers that are close together. Close. Well, how close could we get these numbers? The closest we can get is these numbers being exactly the same. So let's go ahead and do that. Since I'm looking for precision, and just in case to help you out, I'm going to go ahead and I like to brain dump all over my homeworks and notes and quizzes and stuff. That way I know what I'm looking for, and it's right there next to the problem. So question number 1, or team number 1. I've got 2.65, I've got 2.75, 2.80, 2.77, 2.60, 2.65, look at that number, and 2.68. So before I go any further, I'm looking for numbers to be close to each other. How close? I mean, the closest I can get is them being the same. Look at that one. And look at this one. They're the same. That's really good. So I'm just going to, just for me, I'm going to come over here and I'm going to do this. Now, I'm a visual person. I have to see it. And so for me to see it, I see this is going on, but I also see that 0.75 and 0.77 are 2/10 from each other. That is pretty darn good. This is awesome. That number is great, those two. This one is definitely good because they're 2/10 from each other. That's pretty cool. Now let's look at team 2. 2.60, 2.70, 2.80, 2.75, 2.65, 2.62, and 2.78. One thing that I was not able to do is for team 2 is I wasn't able to find any numbers that are exactly the same. Not at all. And since I wasn't able to find any that were exactly the same, well then in that case, let me look for closeness. And in this case, remember, this is 0.02 off. 2/100ths. I'm so sorry I said 2/10. 2/100ths off. Let's see. Let's look at the hundredths place. 78, 75, 70, 80. So this one and this one are 0.02 off of each other. Okay. Let's see. 2.60 and 2.62 are 2/100ths of each other. And then I'm going to start getting to like, look, this and this and this are 0.05 of each other. Okay, so again, we're going to the hundredths place, but it's getting bigger and bigger. So over here, I had a great and I had a good. And down here on team 2, I had a good and I had a good. And if I had to say a winner, well, definitely a great and a good is, to me, is a winner. A good and a good, you look like you're second place. I'm sorry. So team number 1 is more precise than team number 2. Okay, let's turn the page. Next page is going to be a graph. It says here we do a lot of graphs in physics and we use a lot of graphs so that way we can interpret the data and predict and make predictions because of it. Use this information over here regarding the speed. I don't know, maybe this is what, speed of a car or something. Go ahead, use this data, answer the questions from it. So let's look at this data. This is the amount of speed that the object's traveling, and this is the stopping distance. Kind of like some of you, you're like maybe doing your defensive driving right now, or you've just done it over the summer, right? They talk to you about if you're driving faster, it's going to take a longer distance for you to come to a stop. Okay? So, and we can see that. Look, 11 meters per second, 16 meters per second, 20. What's happening here? I see a trend of it getting faster. And what do I see this trend? The amount of distance it takes to come to a complete stop gets bigger, bigger, and bigger. Okay? So now, identify the independent and dependent variables. Again, at this point, this is where you should have your notes out. And I know that some of us are like, oh, Unit 1 is so easy cheesy. She's just going over scientific method, graphing. You know, how hard is that? Well, you know what? Some of y'all had problems on this and got it wrong. And we need to make sure that we know the difference between the independent and dependent. So the independent variable. Well, the independent variable, hopefully, first thing is you went ahead somewhere around here and you brain dumped dry mix. Okay? The independent variable is going to be on the x-axis. The dependent variable is going to be on the y-axis. And the independent variable is going to be what you manipulate or you change. Again, I just want to brain dump a little bit on my homework. And I think you should do this. You should print out your homeworks. After Unit 1, which is what we're doing right now, everything needs to be printed out. That's it. It needs to be printed. And this is one reason. Physics is a class that you need to like kind of just brain dump and put things down to paper. The dependent variable is a variable that's going to change because of the independent. So when I look at this, let's just pretend this is a car driving. What did you change? You changed the speed, the speed, the speed, the speed, the speed. And because you kept on hitting on that gas pedal more and more and more and more, the amount of distance it took for it to come to a complete stop then changed. Okay? So in this case then, we've got the speed as what you are changing, the independent variable, and the distance is going to be the dependent variable. So let me go ahead and put that over here for you. The independent variable is going to be the speed, and the dependent variable is going to be the distance. Alrighty. Determine the range of data that needs to be plotted on each axis. Choose intervals for it, for the axis that spreads out. Make sure your intervals for each axis is consistent. Okay? So what they want you to do is decide what range are you going to go. Are you going to go from 0 to 100? Are you going to go from 0 to 50? And they're asking you, are you going to count by 5s? Are you going to count by 10s? Are you going to count by 2s? That's kind of that's kind of like up to you kind of thing, if that makes sense, right? Somebody wants to go all the way to 50. Somebody wants to go all the way to 100. Now, do we need to go all the way to 50? And do we need to go all the way to 100? I don't think so. Look over here. The highest speed is 29, or the biggest number. And the biggest number over here is 92. Now, because of my dry mix, I know that the dependent is going to be on the y-axis, which is up and down. My independent variable is going to be on the x-axis, which is side to side, right? So, if this is on my x-axis down here, from here to here, the distance or the number range should go always from 0, right? And it should go no bigger than, 30? 40? Why go 40? Why go 50? You don't need it to go that much. This is going to be 0. And this is going to be, I'm going to go ahead, put it to like here. And I'm going to make that 30. Okay, so what about the independent variable? What about the y-axis, which is the dependent variable? Okay, the biggest number is 92 over here. Do I need to go all the way to 200 or 150? No. What's wrong with like 95 or 100? Go to 95 if you're going to go by 5s. If you're going to go by 10s, then go to 100. Okay? So don't overwork yourself. You already do a lot of work. So 0. And I'm going to go ahead and stop about here. And I'm going to call this 100. Okay? Now you need to do your tick marks. And this case is where your ruler that you got in your bag should come and help you. Handy dandy ruler. Okay? Why? Because I do not want to see your tick marks like this. Did I take my time? I'm not asking you to sit here and do unbelievably amazing straight lines and this kind of business and this one right. No, I'm not looking for, that kind of perfection. But I'm not looking for this chicken scratch where I just come over here and just... honestly, let's don't lie. Those lines are pretty darn close to each other, the distance. But they're not perfect. And they're not even good. I'm looking for good. Okay? So when you do graphs and labs, you need to use your ruler so you can make nice... It's not because the line needs to be so perfectly straight. Oh, we're going to need some straight lines later. But here, we're looking for the distance. For the distance between the tick marks to be the same. Okay? So you need to do your tick marks. I'm going to go ahead and go by From halfway between 0 and 30 should be 15. Again, I should use my ruler to kind of look at that distance. Halfway is going to be 50. And I should keep going, right? 10, 20, 30, 40. I just did it with my eye. I didn't use a ruler, okay? But I'm hoping that it looks better than what I did, okay? Now you're going to do, right, your 10, 20, 30, 40, 50. So we did this. Check that. The next one, number 3, number and label each axis, which is what we're doing as well right here. Doing that too. Now, to label each axis, this is my y-axis and this is my x-axis. In physics, we call it our y component and our x component. We also use axis, but we use component also. So I want to toss that word out there to you. Okay, so I need to label my y-axis, which is my dependent, over here, stopping distance. And I need to give myself some units. What is it? Meters. I'm going to put right here in meters. Now, because I did that and I wrote in meters over here, then I don't have to put meters over here. Okay? If I didn't put meters over here, then I should put meters over here. But I must indicate some kind of SI unit behind a number. Okay? Let's look over here. This is my x-axis. My x-axis is going to be my independent variable. If I look, my independent variable is speed, which is meters per second. So I'm going to call this speed, meters per second. And there we go. Now the next one, plot the points. Okay, plot the points. Let's do that. 18 and 11. Let's see, 11. 16 and 32. Oh, I'm going the wrong way. Sorry. 16 and 22. Again, I'm not doing it right. You should have had more time at home for you to do it right. 20 and 49. 60. Right, so 25 and 68, and then 29 and 92. Okay, that's about as good as it's going to get right now. Then I need to go ahead and do my best fit line. There we go. All right, so now I did that. I plotted the data points, draw a line. Oh, okay, I jumped ahead of myself. You always do the best fit line, always, in science. So look at that. I went ahead and did it already, but they requested it. The line may be straight or it may be curved, but our best fit line, we can see that it's going to be a pretty straight line. It doesn't plot and turn. It doesn't turn on us, did it? Give the graph a title. All graphs must have a title. Why are we doing this homework? Because we will be doing graphs for labs, and you do not do your graphs correctly, then I'm going to take points off and you're going to be upset. But miss, I didn't know I needed a title. Yes, you did. Number 1, it's in your notes, and number 2, we did a homework assignment over it. Okay, so there should be no ifs, ands, or buts. Let's make it a title. Our title is going to be speed versus stopping distance. Now, that should be the title. Why, miss? Well, it should be the title because my independent is what I'm changing. And because of this, it's versus, or it's going to change my stopping distance. Because of my speed, then my stopping distance is going to change. So speed versus stopping distance. I think that's a really good title. Some of you may have a different title, which is awesome too, and I'm good. I'll accept it. But don't sit here and give me a title, the fastest car on the block. What? Are you crazy? No, that's wrong. You're going to lose your points. Okay? So your title of your graph should contain the information from your X and Y axis. Okay, so now you know that, not just for my class, but for future science classes. Your title should contain the information from the X and Y axis. Okay, other than that, now you did your homework, you know what the correct answers are. Hopefully you went over with your homework paper, made corrections, and that's why we print it out, so you can make the corrections, right? Does it make sense? If you did it on your computer and didn't print it out, how are you going to make corrections? How are you going to have that accessible to you? You're not. Printing is important. Again, don't forget, if you didn't turn it in on time, it's, you're getting your 0. We're big kids now. We're not little kids anymore in baby high school. We're in college, okay? So it's a done deal. Get your stuff on time, quit horseplaying around, and get your work done. You have to do homework over the weekend, which is homework number 3, and you have next week a quiz. As soon as homework 3 is done, or the due date is in, I'm going to put out the answers, and then we're going to do the quiz. After you do the quiz, I'm going to do just like this, where I'm going to write out the answers and go over why the answers are what they are, if that makes sense, okay? And then we have the test. And then we can look at the test if you want to as well. We can look at that if we have time. I'm not sure how much time we'll have. But please, if you have any questions, email me. I will try to get to them as soon as I can. Have a great day.